All right, hi folks. I'm recording a video for Section 3.3, and Section 3.3 has to deal with quadratic functions. Now, first, let me mention how you'll know a quadratic function when you come across one. Well, a quadratic function has a x squared in it. So usually the way we write a quadratic function is ax squared plus bx plus c. And this is the general form. Let me give you an example. So I might have, let's say, y equals negative 3x squared plus 7x plus 2, for example. I know this is a quadratic function because, let me make this a 2 out here. I know this is a quadratic function because of this exponent 2 on the x. That's what tells me this is a quadratic function. Now, when we graph quadratic functions, they're going to graph as parabolas. So this could either be a parabola opening up or a parabola that might open down. And there's a quick way to know whether the graph opens up or opens down. What you do is look at the number that's multiplying x squared. If this number is a positive number, then the graph opens up. So I'll write here, if positive, the graph opens up, like on this left-hand diagram. But if that number in front of the x squared is negative, then the graph opens down. So if negative, the graph opens down. Well, in my example, the number is negative. It's a negative 3. So because that number is negative, I know the graph for my example is this rightmost graph. So this would be the typical graph for that function. Okay, so you'll know a quadratic function when you see an x squared is present. If the number in front of the x squared is a positive number, the graph will open up like this left-hand diagram. If the number in front of x squared is negative, the graph opens down. All right, let me mention one other item. We're going to be interested to find a certain point on this graph. So when the graph opens up, down here at the bottom is a minimum, we call it. And this point is called the vertex. So if the graph opens up, the vertex is this lowest y value on the graph. But if the graph opens down, like here on the right, then the vertex is this point at the very top of the graph. It's the highest, the largest y value. So we're going to want to know, where is this vertex located? And we'll do some examples in a few minutes to determine that. All right, why don't we go to this question? It says, what if you want to graph y equals parenthesis x minus 4 squared? Well, you might remember we've already talked about transformations of graph back in chapter 2. So what this is going to do is take the graph of y equal x squared, and when you replace x with a quantity like x minus 4, you might remember this is going to be a horizontal shift. And I replaced x with x minus 4. Now remember, this horizontal shift is kind of counter to what you might expect to happen. So because it's x minus 4, you might think the horizontal shift is to the left because it's a minus sign, but it's actually counterintuitive. So this is going to be a horizontal shift to the right by 4 units. Okay, so this is just a reminder of transforming or shifting a graph. Remember, we can either shift it up, down, left, right. We can reflect it across the x-axis. So what they're going to ask you for is, from these drop-down menus, pick either left or right. In our example, we said it was to the right. And how much? A distance of 4 units for our example here. All right, let's go to the next question. The next question is going to ask us a bunch of questions. And let me clear off the screen here. Okay, and let me clear off the answers here. All right, folks, well, let me work out this problem. Here's what it says. Find the vertex and the axis of symmetry to begin with. Then determine if the graph is concave up or concave down, and then graph the function. All right, well, let's start with the vertex. Now, when the equation is in this format, so you might notice this quadratic function looks a little different than the version I wrote a few minutes ago. The way they're giving you this equation is called the vertex form. So this format is called the vertex form. Let me explain what that means. When you write a quadratic function this way, it makes it very easy to determine the vertex. Remember, the vertex is either the top or bottom of the graph, depending on whether the graph opens up or opens down. So here's the general setup. We write it as a x minus h squared plus k. This is the general form of what we call the vertex form of a quadratic function. And if I write it this way, then h comma k is the location of the vertex. And it's really an xy point, but instead of using the letters xy, we use the letters h comma k, but it still means the location of the vertex. All right, let me take our function that they gave us and write it directly underneath here so we could do a side-by-side comparison. Okay, so they gave me -2 x minus 2 squared plus 3. So let me just match up the h and k letters here. Well, notice our h number matches up to a 2, and the k matches up to a 3. So that means our h is 2 and our k is 3. Now I got to be a little careful because the way this is set up, it's shown as x minus h. So I've got to be careful that my equation matches with that minus sign, and it does. It's x minus 2. So that's how I know that h directly matches up to 2. All right, so I know the vertex is at 2 comma 3. All right, they also want to know, is the graph concave up or concave down? Well, to answer that, I can look at the number sitting in front. So I'm going to look at this a number. Notice in our example, a is -2. Well, I mentioned a minute ago that if this number, a, is positive, it means the graph opens up. But if it's negative, like it is here, it means the graph is going to open down. So I know our graph is going to look something like this. It's going to open down. All right, so let me go over and plot this. I know the vertex is at 2 comma 3. So let me come over here, and I'm going to blow this up a little bit. And I'm going to come to the point 2 comma 3. And here is, I'm going to go over 2 and up 3. So this point right here is the vertex. And I know the graph opens down, so you can see this blue parabola here is opening down. All right, so we know this answer is concave down because this a number was negative here. If this a number was positive, our answer would be concave up. All right, well, let's go over here because now they want something called the axis of symmetry. Notice it says x equal 2. Well, you might remember the equation x equal 2 is a vertical line. So x equal 2 is going to be this vertical line. So this vertical line that goes right through the vertex, we call the axis of symmetry. So this purple line is called the axis of symmetry. And I'll know how to write it. It's going to be a vertical line, so I know it's going to have to be x equals. But it's got to go through the vertex. So what I'm going to do is grab the x coordinate of the vertex, which is 2. So I'm going to write the equation as x equal 2. All right, well, the last part is to graph this equation. Now, it's already graphed for us, but how would you graph it from scratch? Well, when you go to graph, what you're going to do is from the menu, you're going to pick an icon that looks like a parabola. So first you're going to click on this graph. Then you can go plot the vertex like I did over here. I know the vertex, I'll plot it. But I'm also going to need another point to plot. And another point that's easy to find is the y-intercept. Let's find the y-intercept. The y-intercept is when x is equal to 0. So I'm going to let x equal 0. So let me go into this equation, and I'm going to let x equal 0. So I'm going back to the starting g of x, and really I'm going to calculate g of 0. This is going to give me the y-intercept. Well, that's going to be negative 2 times 0 minus 2 squared plus 3. Okay, well, inside this parenthesis, I end up with a negative 2. So that's going to be negative 2 squared. But negative 2 squared is positive 4. So this is going to be negative 2 times 4 plus 3. But it looks like that's going to be negative 8 plus 3, which is negative 5. So I have x equals 0, and we really just found a y value. So we found that y is negative 5. So the y-intercept we're after is 0, negative 5. Let me plot that as a second point. So I'm going to come here to 0, negative 5. And this will be the second point. This happens to be the y-intercept. You can see it really is where the graph intercepts the y-axis. And by plotting this vertex and this y-intercept, that will allow you to successfully plot this graph. All right, maybe we could do another example like this. All right, let's take a look at this one. And let's do this from scratch. Now I'm seeing here this is similar to what we just did. So let's work on this one. Let me write this over here. So they're giving us here f of x equals x minus 6 squared plus 2. Well, let me compare this to that vertex form of quadratic equation. And the vertex form looked like this. It said a times x minus h squared plus k. All right, well, let me match up for our example. I'm seeing that h matches up to 6 and k matches up to 2. So when I go to write the vertex as h comma k, in my example, I'm going to write 6 comma 2. All right, so that's the vertex. All right, let me go ahead and enter that. I'm noticing my MATLAB wants an ordered pair, so I'll type it 6 comma 2 in parentheses. All right, let's go to the next part. It wants to know what's the axis of symmetry. Notice it says type an equation. Well, the axis of symmetry is always a vertical line. So the axis of symmetry is going to be x equals a number. Remember, the equation of a vertical line is x equals some number. Well, what I'm going to do, I need the x value of the vertex. Because remember, this vertical line has to go through the vertex. So it's going to go through the point 6 comma 2. So the axis of symmetry is going to be x equals 6. I'm getting the 6 from the x value of the vertex. All right, so let me enter that as the axis of symmetry. I can't just type in 6. I have to type in an equation, so I have to type it as x equals 6. Okay. Now I want to know, is the graph concave down or concave up? Well, to answer that, I've got to look at this a quantity. Now, in our example, I don't have an a, but I'm going to just put a 1 in front. So our a is 1. But notice that's a positive number. When that number a is positive, it tells me the graph is concave up. So I know the answer to this must be concave up. All right, last part, let's graph this. All right, so here's the way you do it. You click on the graph to get started. And notice down here on the bottom is this menu. You have to tell MyMathLab what type of graph do you want. Do you want a straight line? Do you want a parabola? Well, we want this parabola. So I'm going to click on it. One point I know about is the vertex, 6, 2. So let me go to 6, 2. Here's 6, 2. And I'm going to put a dot there. And I know this graph is going to open up. Remember, we said it was concave up. But I need another point in order to graph this. So I'm going to go ahead and try to figure out the y-intercept. Okay. If I try to figure out the y-intercept, let me see if that's going to help me. Well, for the y-intercept, I'm going to let x equal 0. Let me see if this is going to help out. Well, I'm going to take this equation and replace x with 0. And also, instead of f of x, I'm going to use y just to make it a little easier to see that there's going to be a y value. So I'm going to end up with 0 minus 6 squared plus 2. Well, inside the parenthesis, that's going to be negative 6 squared, but that's 36. 36 plus 2 is 38. So the y-intercept here is 0, 38. But I really can't use this for this example because there's no way I can plot a y value of 38. So this is not going to work for me. It is a valid y-intercept and it's a valid point on the graph. It's just that for my graph, the y-axis is only going up to 20, so I really just can't plot this. So let me pick a different x value. Now, how about if I pick an x value nearby 6? Because if I pick an x value nearby 6, that's going to put me close to this point, and I'll be able to plot this on the graph that MyMathLab has given me. So I could pick x equal 4 or 5 or 7, anything like that. Let me go with x equal 4, let's say. You could pick any value you want. I'm going to go with x equal 4. All right, well, if x is 4, then the y value is going to be 4 minus 6 squared plus 2. Okay, well, that's going to be negative 2 squared plus 2. But negative 2 squared is 4. So this is 4 plus 2, which is 6. And that looks good because that's going to be on the graph. So we have x equal 4 and y equal 6 in this point. So I'm going to write as 4, 2. All right, so now let me go back and let me graph 4, 2. So I'm sorry, 4, 6. So I'm going to come over here to 4, 6. Looks like it's right there. And that should do it. Let me fix this. This should have been a 6 here. That was a typo on my part. So let me fix that. This should have been a 6. So I'll make that a 6 and make that a 6. So we plotted this point here as 4, 6. And of course, we plotted the vertex here as 6, 2. And by putting those 2 points on the graph, MyMathLab was able to draw the parabola connecting those 2 points. All right, hope this is helpful as you're working in Section 3.3.